So today we're going to be diving into C++, and this is going to be the first introductory kind of programming session today. Today is going to be an exception to normal days where we're going to be mostly, I'm going to be describing and explaining kind of the first parts of how C++ works. And normally what I do is I give you guys a lab to work on stuff based on a lecture. But today we're talking about a lot of different things that kind of like a baseline. What I'm going to do instead is I'm going to write code. I'm going to have you guys follow along today. And I'm going to have you guys start up Visual Studio and make sure that the code that we're working on works on your machine as well. First things first, I do want to go over the homework as to how to get a sample project started. And then we're going to dive into C++. And some of the very first things you need to learn in C++ is, one, how do you write a program that runs? And then two, what constitutes a program anyway? What kinds of things do you need to make a program do what you need it to do? And to that effect, we have to talk about variables today. And in addition to variables, we have to talk about I/O, which stands for input and output. So we have to have a way to get input from the player as well as present information to the player. Now, in our case here today, we're going to be talking about I/O as it stands with text. So you're going to be seeing a lot of text today, and we're going to be working with text for the remainder of the quarter. However, I/O doesn't just mean text. It can mean something like, hey, pick your race in World of Warcraft, pick your class, right? Or, hey, you have a row of abilities in League of Legends. Which ones do you want to use right now? And output to you can be things like, hey, this is where a mini-map is, and this is where your character is. So for us, for this class, we're going to be mostly focused on text-based programming, which means we're going to be working in a console window, a black window with white text. When we move towards making games like tic-tac-toe, we're going to start doing some work with graphics. So graphics in this case will be traditional kind of 2D graphics in C++. So we're going to be learning how to eventually draw things like circles and squares and write text. And really, a lot of games revolve around just that. And you throw some textures in there, and you can make a game like Asteroids or Tetris or Pong or Pokemon, like the classic ones. And a lot of that stuff boils down to the same concepts, where you're going to be learning how to use variables and types to make your game. Okay? All right. So what I'd like everyone to do is make sure that Visual Studio starts up. So we're all going to be working in Visual Studio 2015. Just to make sure that you guys are able to go through this, because I'm about to go through the homework with everyone so that everyone has the same kind of sample project. Okay. So first I'm going to go over homework, and then I'm going to dive into the new stuff for today. Okay, any questions before I get started?
Where did you want the homework?
Oh, yeah. So I made a folder on Zool, and there's a folder called SDVA 103. In that folder, I want you to make a new folder with your first initial and last name only, and then put your homework in there. And I will go over and make sure you have it. Okay. Okay. So everyone should see something like this, right? Visual Studio 2015, and I briefly kind of went over it, but I didn't really spend a ton of time on it because I wanted you guys to go through it on your own at home. So I want to go over how to make a new project, which will be the way that you're going to make your games from here on out. Okay? So Visual Studio has a ton of features in it. It has a lot of stuff that you probably don't need to use, which is why I think it's important to make sure that you are following instructions. Otherwise, you might get caught up in stuff that you don't care about. Typically, the first thing you see is like a start page, and like this is kind of like just like the MSDN Microsoft page to say, hey, here's all the new stuff that's going on with Visual Studio, and here's some tips and tricks. We don't really care about that right now. So there's two ways you can approach making a new project. Visual Studio has like a quick start here on the left, as well as you can make a new project here as well through the file menu. If you decide to make a new project here, you get presented with this giant dialog with all these different options in it. So you got to keep in mind that Visual Studio is not a C++ writing program. Visual Studio is what's called an IDE. So an IDE is an integrated development environment. What that means is that it integrates many different tools and many different languages combined to let you make something. So typically, if you didn't have Visual Studio, the way that you write a program is you open up literally like something like Notepad, you write your program out, you save it, you run a separate program to compile it, and then once it's compiled, you then separately double-click or click on the resultant executable to run your game. Now, if something goes wrong, you're probably ended up like, oh, like I'm not sure why something is happening in my project. You have to go back to Notepad and edit it some more, compile it again, and then run it and see if it fixed the issue. Visual Studio basically combines all three of those things into one place, plus it adds something called debugging tools, which we'll get into later, as far as to help you figure out why your program might not be running. In addition, Visual Studio supports many different languages. So out the box, the ones that are installed here, it supports all these languages here, these templates. So you have Visual C#, which is a language that's typically, it's kind of like Java. It feels kind of like Java, but it's based on C++ a little bit. It is kind of like Microsoft's programming language. It uses what's called the .NET framework, which suffice to say, like all you need to really know about the .NET framework is it has a bunch of features in it that you can use to make like applications for Windows. Okay, Visual C# is an excellent tool for writing. Like, if you want to write, like, say, I don't know, like a variant of Photoshop, right? For instance, our editor in Overwatch is written in C#. Okay. C# just has a lot of nice things in it that let you make tools that work with file systems and work over the network, and it just makes it a lot easier. Visual Basic is a very simplified version of, it's kind of like sometimes it's people's like first programming language. It's called Basic. Visual Basic is a way to take what's normally a command line programming language and move it into something that can be used for writing tools. The one we care about, though, and the rest of these things are also relevant, but you can we're not going to be using any of these, but there's a time and place for all of these. We're interested in Visual C++. Now, when you click on this, you get a lot of different options here. And it can sometimes be confusing as far as which one you want to use. We're only going to ever use two of these. And really, there's only two choices that you guys have to worry about. One, you can either make a Win32 console application, which is this guy right here, or you can make an empty project here. Now, the appendix in the book says, hey, you should make an empty project. And that's totally fine, and you guys can follow that, and so that's what I'm going to do today. But you can also just make a console application which handles, writes a little bit of code for you, just a little bit, to help you get on your way. So I kind of want to show you guys both. And first I'm going to start off with a console application just to show you what that looks like, and then I'm going to go into the empty project and show you how to do it through the books method. Okay. So Win32 console application is what I'm going to choose. You typically pick a place where you want to put your application. Consider this the location where your game is going to go. Okay? This is going to be the folder where all your code and all your assets go. So in this case here, and you guys can follow along if you want. It doesn't hurt to make more projects. It's always easy to make new ones. We're going to make a console application here. And hit OK. It's going to present me with more dialogues. It's kind of like a wizard. It tells you, like, hey, you have some choices as far as how you want to make this application. What do you want to do? These choices here are ways that it's going to configure the project for you automatically. Some of these things here, you can turn on and off as you want. These are kind of like quality of life choices. For instance, this thing here makes it so that it'll tell you if you're trying to use features that are not safe. So if you're writing like something that needs to be secure, and like a little bit, not really, but a little bit more stable, you can turn this on. For the most part, you won't really ever notice if this is turned on or off for what we're doing in class. And then this guy here, this one I typically turn off. Precompiled headers are important typically when you have large projects. And the larger your projects get, the more important this is. And I just want you guys to treat this as, hey, if you turn this on, you basically have to add a little bit of code everywhere, but it'll make your whole project compile a little faster. For us, I turn it off because it simplifies everything. Right? So I turn off this precompiled header. I click Finish. Okay, so this is what you see when you make a console application. So I want to break this down a little bit because I want to teach you guys a little bit about how Visual Studio works. Because Visual Studio offers you many different things, many different tools, one of the main things is, and the biggest, is the text editor. Okay, so if you're going to be learning how to program, you're going to have to be editing text. I'm sorry, that's just how it works. If you cannot deal with a text editor, we should talk because maybe programming is not right for you. This is what C++. This is like kind of like the bare minimum of what Visual Studio will add for you. This is what you need to actually make a program that runs. So right here is the text editor. We're going to get into details of this in just a second. I want to go over what's over on the other panes here. On the right side here is another very important part to Visual Studio, which is the Solution Explorer. You can think of this like a Windows Explorer, like a Windows file browser for your game. Okay? This thing will contain everything that your game will use, which mostly consists of source code for now. So you have here, you see I have a C++ file here. So I go on the right, I can double click on it and it will open it up. So if I happen to open up a project and nothing is open, which it sometimes can look like this, I go to my Solution Explorer and I see that I have all these files and I can double click on the one I'm curious about. All right. Anything you have selected here will also show up in the property grid down here. This just kind of allows you to see where that file exists on your hard drive. So you can see here the full path here. And it also will tell you what type of file it is. Hey.
I don't know if I did something right. Did you say start console application or did you project?
Console application. We're doing console application to start, and then we're going to go to.
I did that, but I didn't get what that was.
Looks
I
like
came up
you
with an
have.
empty screen.
Okay, cancel this because it looks like you're making another one. Oh wait. Hit cancel. Sorry. So you're going to see what I saw. So if your project ever looks like this, this thing will close. Like that, right? Look at your Solution Explorer on the right, and you can double click on the CPP file that you're interested in.
There's nothing in there.
Did you make it?
Source
Did you make it empty project?
I made a console application.
But
But nothing came up.
Okay, make another new console application and start over from scratch.
She clicked the empty.
Oh, if you click empty, that'll make your project empty. So do it again. Just hit OK.
This one.
Say no.
no.
Oh.
That's fine. Hit next. So wait, before you go anywhere, you need to make sure you probably checked that one here, is my guess. So I just want you to hit finish here. Don't do anything else. Okay, cool. Now you're caught up.
I was trying to I have a question.
Thanks.
I have a question.
Hey.
So on Mac, I guess, is it different between the Visual
Yes.
Studio Code?
Yeah, you can't use Visual Studio Code is not an IDE. It's simply a text editor, so you're not going to be able to use that to follow along if you want to.
Yeah, I just figured that out.
Yeah, I would just follow along. All right. Anyone else having issues making a console application? Okay. I don't even see a console application.
Brings me back to the high school days, like 2 years after I dropped after I stopped Visual Studio.
Okay.
That's
How long ago was that?
Once you type out Visual Studio,
Yeah, it's definitely come a long way since then.
Just a little bit.
yeah, console application. We want to start one of those up.
I learned HTML and Notepad.
Oh, you're starting
And I still code.
That's
I
actually not
still
the
do HTML, CSS,
That's actually so. Go ahead and close
Do
that.
you like it?
That's
I prefer to do
Well, Notepad plus plus is awesome.
I just like the language and go.
Type out the whole thing. Visual Studio 2015.
See, I never really got into HTML. I knew a little bit about it, but just never got into designing.
I got into HTML when it was HTML
There
on the last
result
one.
there.
Now it's like HTML5.
Make sure you're not starting
Yeah,
out
I can do graphics.
That was doing HTML before Flash.
blue screen.
And then when Flash came out, like, no.
This should be similar to what you guys did at home. However, we're making a modification set. You guys all
I just read that.
That's good? Okay.
It's merging with something else.
All right. I do want to preface, this is what my work environment looks like. This is what I program every day, day in and day out. This is what my job title is to work inside Visual Studio. Okay? And of course, I do stuff outside of it too, but a lot of my time is spent in here. So I'm intimately familiar with this program. I've used this program since it was Visual Studio 2005, I want to say. Yeah, it's been a long time. I think it used to be called Visual Studio 5. They started using year names at a certain point. So I want to talk about this because it hasn't really changed too much, like the visuals of it. I mean, a little bit, but I do want to talk a little bit about some of these other features up top. Okay, so if everyone has this, once you have your file open that you want from your Solution Explorer, you have these other buttons at the top that control how you want to run your program. So first off, you see a little green arrow that looks like a play button that's connected to local Windows debugger. If you click on that, this is one of the ways you can get your program to run. The first thing they'll ask is, hey, your project's out of date. Would you like to build it? So I want to take this moment to say, when you're writing code, how do you convert that code into an executable that you can run? Overwatch, for instance, has a literal executable on your hard drive that you double-click to start. How does it get from what rewrite as code into that executable? It has to go through a build step, right? Something has to convert this code that's text into something that Windows can run. And that step is the build step. Now, the build step has multiple parts to it. However, for your guys' sake, you just have to know that when you try to make a new executable, you have to go through this step. However, this step won't always succeed. A lot of times, it'll fail. And that's okay that it fails. What that means, though, is that your code that you wrote, it doesn't understand something, and it can't make the executable, which means you won't have an executable to run. For us, though, every time we go to run the game, it'll ask and say, hey, I think something has changed inside your source code. Do you want me to build it before I run it? And this is what this dialog is. It's saying, hey, you clicked on the play button. Cool. But I don't have an executable. Or the project's out of date. You need to build it again. So you get this choice here. You can say yes. It'll go through a build step on the bottom. It's very fast. Generates an executable, runs the program, and then exits immediately. Okay? Now, that happened really quickly. However, the results of it are clear. For instance, now if I click on it, I don't get that dialog anymore because nothing has changed. Okay? Second, I now have an executable here that got created as a result of this build step. Okay? Every time, if I delete this and run it again, gives me that dialog, builds, and then generates me the executable. Okay? I showed this a little bit last week, but this is how you get to that point. If I delete this, there's another way you can build it. Let's say you just want to see if your program compiles. This is an important thing. A lot of times I'm writing code, and I just want to make sure that the code I just wrote is correct. But I don't want to run the game because spinning up Overwatch and testing it can sometimes take like 10, 15 seconds, which doesn't sound like a lot, but it can take a while. What's that?
But it builds up
By builds
10, 15 seconds every time you want to test something.
to spin up the game. Yeah, I'd say run the game, and it takes 10 to 15 seconds just to spin it up, and then another few seconds to get into the game of Overwatch. But you don't always have to do that. Oftentimes I'm writing code, and I just want to see if it compiles. So this button here will run and compile. It'll compile first and then run it if it succeeds. However, this build menu here is where you go if you want to just test to see if your project will build. And the most common thing you're going to do is the build solution button at the top, where it says Control-Shift-B as a shortcut. So you can click on that, and all it will do will be compile and not run it. But it will make an executable for you. Okay? So oftentimes the way that I work, and this is kind of the pattern I want everyone here to adopt as well, is when you write some code, whether it's a little or a lot, the first thing I want you to do is I want you to build it. So I go up to the build menu, go do build solution, and if everything worked correctly, you'll see that this log at the bottom says that the build, the last line here will say how many succeeded and how many failed. So I have one succeeded. That means one of my projects succeeded. And then how many failures I have, which means how many errors do I have in my program. Okay? In this case, I don't have any errors. Because everything succeeded with no errors, I go in here and I expect to see an executable, which is what I do see. All right? So the way that I want you guys to work is build first, make sure you have all these successes, and then once it's done, then I want you to run it. And you can run it by either clicking on this button here, or next to the build menu is this debug menu. So we're going to get into some of these other features, like stepping into, stepping over, and breakpoints in a later lecture. However, for today, the most part of what you need to use is this start debugging. Notice it has the green arrow just like the button on there. But note the little shortcut on there, you can hit F5. And almost always when I'm running, I will hit F5 if I'm in my program. And F5 is a shortcut for running it, which will then spin it up and then close it down again immediately. Okay? All right. That's the general basics of how we're going to take our code and we're going to compile it, and then once it's compiled with no errors, then we're going to run it. Okay? Questions? Okay. So the big difference between what you see here and what Overwatch uses to make, what we use to make Overwatch is the volume and the number of files that we deal with. Okay? Overwatch has probably hundreds of thousands of these like C++ files, each one dealing with a different section of the gameplay or the engine level of Overwatch. While for us, we're mostly going to be focused on one file for now. However, keep in mind that later on, you will be dealing with multiple files. And that's more for like the couple classes from now. However, in this case here, even though we're only dealing with one file, it's going to basically be the same concept. If, for instance, you were to start on a new game development team today, and you were asked to build the project, you would do exactly the same thing. You go to the build menu, you do build solution, you see if everything succeeded, and if it succeeded, you hit run. Okay? All right. So let's actually write a program now. So I'm going to make another new project. This time it's going to be an empty project. And an empty project literally has nothing in it, but it lets you start with exactly what you want, and it won't write any code for you. Notice that when I made an empty project, there was no wizard or anything like that. It didn't ask me if I wanted to use precompiled headers. Didn't ask me if I wanted to use the SDL flag. I'm just making a new project, okay? And when you make a new project, you literally have nothing in there. So what we're going to do is we're going to follow basically what the book has, and we're going to make a new C++ file. So these folders on the right let you choose where you want to put those files. Typically, for us, we're going to be dealing with these two folders, header and source files. We're going to get to header files later. So for today, we're going to be focused on where we're going to be putting our C++ source code, which is going to be the source files directory. These are what are called filters. They're not actually directories. They look like directories. However, they're a way to organize the code. If I right-click on this guy, I get an add menu, which lets me add several things. I can either add a new filter, so I can add new folders, or I can add a new item, which lets me add a new type of source code, which is what I'm going to do now. Okay. Go ahead and add a new one. You get this option here. I want to describe these two things. C++ files and header files. The difference between those is just the file extension. That's all it is. They're literally both going to be empty text files. Everything you're dealing with in code is going to be empty, yeah.
Oh no, the computer doesn't have it.
doesn't have Visual Studio, are you sure?
Yeah. When I like type in the whole thing, it seems to pop up.
Actually, try looking through all programs.
Okay. When you add a new file, C++ and header files, it says it looks different. Overwatch pretty much has like just C++ and .h. They're all the same. They're just text files. There's nothing special about them. Literally, they could probably have a .txt extension, and that's okay. You can still compile those if you want to. These extensions on the end are more as used for hints. So Visual Studio kind of has a general idea of how to treat these text files. And by default, if it sees a CPP file, it says, "Oh, I should build that guy for you." And that's what we're going to add. We're going to add a CPP file. I'm not even going to rename it. I'm just going to call it source. And you get this nice blank template. All right, questions so far? Everyone should have a nice blank file. We're going to do the simplest program ever.
What PDF file are you going from?
This is the from the homework.
The beginning C++ pre-game program?
That's right, the Appendix A part. Don't worry, you could just follow along here. I'm about to go through it together up top. So, when you're writing a program, you typically get your choice of like how you want to display this file. For the most part, though, it's all going to be. This should all look like this. You can control the themes and stuff if you want to, but for now we're just going to deal with this. And I just want everyone to follow along and write what I'm writing here. And this is basically the homework. Okay? The first thing is going to be this #include IO string. You'll know if you typed it right because there will be no red squigglies and it'll be color-coded correctly. Okay?
When I'm typing it, a little box appears at the bottom of what I'm typing.
I'm going to talk about that in a second. That's what's called IntelliSense. That's what helps you write the program. Oh, so you have a new project, so you don't see the Solution Explorer, and you don't see the View menu, and just put Solution Explorer at the top. There it is, and now you can write the source files. Okay. Yeah, when you are typing stuff and you see this little dialog pop up, this is one feature of Visual Studio that helps you write your code faster and more correctly. In this case here, I started typing the word IO, and it's essentially an autocomplete that fills in. It fills in with all the things that it finds and tells you where it found it. So in this case, IO stream actually lives right here. You see a little pop-up tooltip that tells you where that thing is. So what this is actually doing is it's just including another file to be part of your source code. This other file, this is actually just a file that lives on your hard drive. We can actually just open it. Nothing crazy special about this. We can just open this guy. Let's find. This is at C program files, Visual Studio VC include. Okay. So we can actually go to this. Microsoft Visual Studio 2015. So this file is right here. Okay? Nothing magic about it. It's literally right here on the folder. And this is what the file looks like. Has a lot of code in it. Thankfully, you don't have to read any of it. All you have to do is know that that is the file that you are including right here. When you're including it, it means that, hey, I actually want to use what's in this file in my program. And just to summarize, all this thing does is it gives you a way to print something out to the screen. That's what IO stream is. It's input-output stream. It lets you write something to the screen as well as eventually read something from the player who's playing your game. It lets them type in something so they can put in their name or type in their class choice or whatever else you want them to do. Okay? The next thing you need is to tell C++ where your program starts. There's a very special set of words that you need to use in conjunction. This is called the entry point of your program. Every single program written in C++ has to have one of these. Okay? It has to have some kind of main function. Now, it's going to mostly look like this. There may be some occurrences where you see some additional arguments in here, like this sometimes. You're going to see some other arguments, like there are some things in Windows that's like winmain. However, for the most part, you're going to be finding things in programs. If you're reading files, this is where the program starts. When you run your executable, it's going to be looking for this to figure out where's the first line of code I need to run for my program. Okay? Notice here I write int main parentheses, and then I have a set of curly braces here. If you notice when you typed in the curly braces, Visual Studio actually auto-completed the curly braces for you as soon as you type the left one. And all you have to do is hit enter a couple times, and it will actually put new lines in for you. Okay? All right. The next thing we're going to do is exit the program. This right here tells the executable, hey, I'm done with all the code I need to run, and I'm telling you what the error code is for my program. You might not have known this, but every program that exits returns whether it succeeded or failed, or some other number telling you how well that program ran. If you return 0, that means everything's hunky-dory, no problems. However, most oftentimes you'll sometimes return like an error. There are special error codes that you can return, and typically you're using very specific ones that you are listening for when you write programs. For instance, when you're like building lighting is a common case where you might run a separate executable, and maybe that executable returns 12 if lighting wasn't built properly, right? And so that's what we're telling the executable here. We're telling essentially Windows that's running it what the return code is. Okay? If it did nothing else, and now if I build, and I go into build, and then build solution, I should see 1 succeeded and 0 failed, and I should be able to run this program, which will then pop up a window and then close immediately. Okay? I want to make sure everyone can compile it and run. So whatever you typed in, make sure there's no errors, and then we'll continue on, and I'll continue the lecture. You have int IO stream return 0. Okay. Did you make an empty project?
Yeah.
Did you build your solution?
Yeah, that's what I was
Click on that. Can you click on the little arrow next to that? Click on the source file
It's
here.
quite advanced.
Can you show me how you made your new project into the same thing as that?
Well, cloning the repository off GitHub for my group project. It's not even that big. It's taking forever on this one. It's the code club.
Can you go
Do
over?
two-person projects.
Can you open up? Can you retype that code real quick and see if that compiles again? Everyone got it compiled for the most part? Some people are hiring.
When I press play on this thing, Samus is supposed to show up running around, so I gotta draw a level for her.
How dare you?
Though honestly, in the original Smash Brothers, I thought Samus was a guy too.
Yeah, I didn't
I just want to make sure everyone is getting the right pieces here. So something to keep in mind is that case matters. You can't use capitals where you need to use lowercase instead. Anyone else having problems running? You look like you're having issues. Did you do build and then build solution?
They're still starting. I wish that he was here when I first started.
It's building.
I would have had to teach myself.
You're the only one. Okay. So, what I think must be happening, are you running this off your hard drive by chance? And scroll up a little bit.
Yeah, I'm teaching. I haven't worked on Saturday, or I haven't gotten very early. I'm not even. I only took this first one last
Do me a favor. Can I drive for a second? Something's wrong with your machine.
I worked at Termite Company.
See how my first thing is right here?
I worked there for like 2 years now.
All he wanted was just Texas.
At the very least, when I graduate, if I can't find a job in the field, at least I still have a job. So I won't be like totally covered. I mean, pretty much.
No.
Yeah, probably. It's alright,
That's what you said earlier? Sure.
Portfolio. I have maybe two. I got
Other project you were
You don't have to do this for now. You can currently see. So I don't know why the project for you is jacked up.
Yeah, those are fine.
But he was like, you're crazy. Okay, so why don't you do this? How would you write it down? And then
Okay. Let's finish this simple project and let's get to the other part. And I'll give you guys a little bit of a break soon, so you guys can go get whatever you need to. I want to print something out to the screen saying some string that we want, whatever we want. You can write memes if you want to. This is a longer one.
let's go with the classic.
I'm checking it out right now. Apparently, Sam's supposed to be here.
You don't want to do that.
Yeah, he says,
I'm gonna fix it probably.
Go with the classic. At a meeting yet? Or
I think they're over there. I don't know. I just haven't gone.
you don't want to do a hello world?
Hello. It's game over, man. Game over.
hello world from the new C++ programmer.
There's one more piece I'm going to add to this because the book in the appendix asked to make a batch file that would run this, and I don't think I'd rather just run it from Visual Studio, so I'm going to change it a little bit. And I'm going to do this in almost every program that I write in this class. So these last two lines here are going to be very common. Let's see. Okay, I want you guys to write this. Put whatever you want in between the quotes. Make sure it should work. Oh, and you're missing the include IO string.
Yeah.
You can't just replace it though. You can't remove that thing that's up there. Add another line that does it. Woohoo! So what should have a simple console. There's actually a lot you can do with this. Just this line, story. And make your computer say and do things. Anyone having issues, not able to get their console off? Gone.
Yeah, I think he's using their own animation though. It looks like it's a jumping animation. They're cycling through jumping.
It's just so your pals. I accidentally showed it.
Everyone got it? You guys all ready to get a job? No? Easy? I just want you to take a moment and realize that this program that you're running, you actually wrote code that made an executable on your computer, right? I don't know, when I realized that, oh, all of a sudden I can be the one making executables, and like normally all the way up to this point I've been running everyone else's, I thought that's the coolest thing ever. That you can take this, you can copy it to any other computer and double click on it and run, which I think is really neat. A couple things to explain here. One, that first line, the std : cout, and the rest of it, that is what outputs the string to the screen, obviously. And there's a few parts I want to break down about it. One, the thing that you're actually doing is you're taking this, which is a string, and a string is just basically a series of characters together. It's defined by a set of double quotes. And look at the direction. Look at these arrows here. Those arrows are essentially pointing in the direction that you're feeding the string into. So if you look, if you imagine that these arrows indicate the direction of flow of like information, you have this string here getting fed into this object here. And this right here is another string. However, you can't really see it because it's a different name for a string. ENDL means the end of a line, means you're putting essentially a return. Notice where my little cursor is blinking here?
Yes.
Right? And then it's going to feed that into there. Okay? Even with just this, we can do a little bit of cool things. So keep in mind, I am feeding these two strings into this cout object. This cout object is basically the terminal. You can imagine that cout as this window here. I'm feeding that into that window. And if you look at this next line, I have something called a variable, which I'm about to get into, which is part of the lecture. I'm calling it dummy. Because dummy here means that it doesn't do anything. It just sits there. And I'm calling it that because I'm taking input, which is what this object, and look at the direction of the arrows, they're feeding into dummy, which means this program is going to wait until I type in something. And as soon as I type in something, it's going to close. Okay? Because what happens is that it gets to this line right here, and the program stops. And says, OK, I'm going to wait here to see what you type in. And once you type it in, it's going to exit immediately. Okay? So a few things here. You can do multiples of these lines. And for every single one of these lines, you're going to print out another piece of text on the screen. Right? So I have 4 of those lines, and each one of those lines is on a separate one. If I decided to, you can also omit this from each of them. Which which means all of them will go on the same line, like that. Also, you can put all of these on the same line if you want to. Now, you can write one really long one, like this, which will print out all those because it's one string, or you can do what's called concatenation, because remember, those arrows indicate what we're putting into there. I could just put another set of arrows and do the same thing if I wanted to. This is useful in case you have variables that you want to output to the screen. All right. So what I'm going to do is I'm going to give you guys a short break because we're going to get into the lecture portion. That's going to take about an hour. And then I want you guys to come back. And we're going to go through the variables and different types of variables in C++. So be back by, let's just say 10 at the latest. I'm going to start at 10 on the dot. And we'll resume lecture then. Okay.